Now we are going to see three important basic ideas that are required in analyzing a structure: supports, reactions, and equilibrium. Let us assume there is a wall and you are trying to push the wall. So we take that this wall is a very strong wall. You won't be able to move it. It is a very stable wall. So when you push it, the wall doesn't move, but you tend to feel a little pressure at the point where you are in contact with the wall. That pressure is nothing but the reaction. You are making a force on the wall, and there is a opposite force getting generated on the wall, pushing you back and keeping everything stable at the same time. Okay, this reaction that is coming from the wall is equal to the force that you are applying on it, okay, by your hand. Okay, this application of force creates a reaction. So similarly, when you keep a book in a table, there is naturally gravity at any place in the earth. So the book tends to move downwards, but the table in this situation is a rigid body. So whatever the gravitational force created by this book acts as the force created by the book, and the table in the table there is a opposite force created to keep the book stable on the table. Okay, so this opposite force created is called as reaction. So this is nothing but the Newton's third law. Every force has a equal and opposite reaction. So if you read this, a force is equal and opposite force exerted by a reaction force is the equal and opposite force exerted by a object in response to action force from the first object, which is nothing but in this place the force we create by our hand, here the gravitational force created by the book itself, and because of that there is a reaction generated. So based on this, we have three basic support conditions which create different type of reactions. Okay, this is a very basic thing. Let us see. When you place a beam on a column, you just place it. It is just kept on it. There is no restraint on the sides. It is just kept on it. Then that is equivalent to having a hinge with a roller at the bottom. If there is a roller at the bottom, what happens is this beam can move like this. It is allowed to move in the horizontal way. So if any kind of a load applied on this beam, the support can move horizontally if the force is horizontal also, or it has a horizontal component. But this support cannot go below because of this restraint from moving downwards. A vertical reaction is generated. Now let us take another support called pinned support, which has a restraint on the horizontal also. this horizontal movement is restricted here. You can see that the horizontal movement is restricted here, but here the horizontal movement is allowed. So because of this horizontal restriction, what happens here is when any kind of load is applied on this beam, in a vertical or inclined which has a horizontal component, this beam cannot move horizontally as well as vertically. Because of that, two types of reactions are generated. That is, vertical reaction and horizontal reaction is also getting generated because there is restraint. If the movement is allowed, then that force is utilized for the movement or displacement. But here, since we are restraining, the reaction is getting generated. Then there is the fixed. So in this case, the beam is integrated with the column. It is not placed, it is integrated. So the vertical movement is all restricted, the horizontal movement is restricted, and one more thing, even the tilting motion is also restricted. So if you remember our moment, so when the load is applied, when this beam tends to bend like this, the beam will tend to bend like this. At this place, this particular portion will move up like this, and then it will bend like this. This movement is allowed here. Similarly, here also the bending movement like this is allowed. But in this case, it is restrained. Because of that, the third reaction, moment is also generated here because the rotation is restricted. Because of that, moment is generated here. These are the three very basic and very important concepts that we should understand for analyzing any kind of a support system or any kind of a system for that matter. Now, again, so this is to reinforce what we have seen. So this is a simply supported any structure. Here we are assuming it is a pipe resting on a block of concrete. Here it is just resting on the beam. So this is nothing but a pinned support with the roller. So this is called as a simply supported condition. So vertical reaction only is possible here. Then there is a beam with a pinned support where the rotation is allowed. Okay, similar to this rotation is allowed, but horizontal movement is restricted. So this is a hinged support. Okay, are you able to understand? So vertical and horizontal forces allowed. So here it is a beam which is fixed. Almost all of the framed structure, this is the condition we will be seeing. A beam is integrated with the column. Here all the three reactions are generated. Now, so a roller support will have vertical force and the resisting vertical load. So a pinned support will have horizontal and vertical reaction. So it will have a vertical and horizontal load. So fixed will have all the three reactions are generated here. Now coming to the next important concept, the equilibrium. So let us say two people are playing tug of war. So they are pulling the rope equally in each direction. Then there will be no movement. Okay, this condition, the force generated by either party is equal. That is why this system is in equilibrium. They are not moving in any direction. This is called as summation of forces equal to 0. That is, this person is having a force, let us say, here he is giving F1. This person is giving like this F2, because both are in opposite direction, it is nothing but when you do F1 plus F2, it is nothing but F1 minus F2 is equal to 0. Here it is F1 is equal to F2. So when you rearrange, it becomes F1 minus F2, which is equal to 0. That is the summation here. Similarly, here we see another thing. We will call this like force and resultant. Here, two people are pulling. Here, the F1 and F2 are there. There is a equilibrium force on the other side, which we call as resultant. Okay. This in this place also the summation of force is equal to 0. This system is also in equilibrium. A plane flying. So here the plane is stable in the air because the weight that is pulling downward and the uplift is equal. Similarly, the thrust forward and the drag at the back is also made to be equal. Only then the plane can be in stable condition in the air. So this is also called as a equilibrium condition. So here if we look at it clearly, it is Fx is equal to 0, that is horizontal force in all direction is equal to 0. Vertical force in all direction is equal to 0 when you add it. Similarly, if there is a third direction, the third direction, that is in Z, the force number summation of force is equal to 0. So if we take this direction as positive, you'll have to take this direction as negative. Similarly, if up is positive, down will be negative. You should remember that. That is how you do the summation. Then you get this value is 0. This is called as equilibrium. When the forces acting on an object are equal in size and opposite in direction, the object experiences no net force and it is considered to be in a state of equilibrium. So this summation of forces is equal to 0 is equilibrium of forces. Now, similarly, you look at this place, two girls are playing in a seesaw. So if Mia's weight and Amy's weight are same, the moment they are looking sitting at the almost equal distance, the moment generated by both of them are also equal. So this side it is the moment is in anti-clockwise direction. This side it is in clockwise direction. So when you make a summation, what you get is the summation of moment is equal to 0. Here the force is equal to 0 and the moment is also equal to 0. These are the two important equilibrium equations, that is summation of force is equal to 0, summation of moment is equal to 0 in the system. Then the system is in equilibrium. I hope we have been able to understand this equilibrium also. Thank you.